the scientific method, we're talking about what do scientists do to help them learn new information. How do they do that? And they do that by sort of following a certain way of learning things. We call it the scientific method. There's lots of ways that you can do it, but we're going to talk about one specific type of way to do the scientific method. You're following a set of steps. So you have some vocabulary. There's some vocabulary that you will need to know in this unit. And you have the list there. These are some of the terms that are going to be important. We're not going to go over them all right now. We'll go over them in the next couple days. But you have a list there that might be helpful for you. But before we talk about this much, let's think about an example. Let's think about a student wanted to determine the effects of different colored lights on plant growth. So she set up an experiment. She grew 2 plants under the conditions that are shown over here in this diagram. All right, so this is how she set up her experiment. 2 plants with all of these conditions. And then at the end of the experiment, plant number 1, it grew 10 centimeters. Plant number 2 grew 5 centimeters. And so she made the conclusion that plants grow better under red light. What do you think about her conclusion? Is that a good conclusion based on how she set this up? What do you think, Sophia?
No, because plants don't just grow in the
Okay, she gave him some water though. You got water. Any other ideas, Lily?
Or like different kinds of plants.
Would that interfere with the experiment?
Maybe.
Anything else? Frank? What about it?
Well, 116,
Yeah, that's different as well. So, yeah, plant 1 grew 10 centimeters. Plant 2 grew 5 centimeters. But they got different amounts of water. They are different temperatures, like Frank said. So, let's go on here. So, yeah, this isn't a good experiment. We can't be confident in her conclusion. Okay? So, how could we change this experiment? That's what the second question is asking us. How can we change this experiment to make it better, to improve upon it? Okay, what can we do?
So like everything's better, like everything's equal.
Oh, everything?
Yeah.
So you should make all these things equal? They should have the same color light?
No, not that same color light.
Okay.
Just like the water, like the not the light, the same type of plant, how long it is.
Yeah, you're exactly right. And that to do this experiment properly, we want the light to be different. Okay? We want one to be grown under red light, one to be grown under blue light, because that's what she's studying. But like Vinny said, every other factor, we call those things variables. Every other variable, we should have it the same. The same temperature, the same water, the same amount of time they're growing, and the same type of plant. Then we have a better experiment. So go ahead, fill that stuff in, please. So now if she set this experiment up this way, would you think it's a better conclusion?
Mm-hmm.
Yeah. Because in the first original way it was set up, we don't know, well, did plant one grow more because of the light, or maybe it was because it got more water? Or maybe it's because of the temperature, or because it was a lily. We don't really know. We can't be sure because we change many things at once. And we're going to learn this when we have a good experiment. We change just a single thing at a time. One variable is changed, and we try to keep everything else as close to the same as possible. All right, so we are going to learn that there are 6 steps to the scientific method. Now, like I said, there's other ways to phrase these, and sometimes they're not in this order, but for us, we're going to say there are 6 steps to the scientific method, and you're going to have to memorize the names of them. But luckily, we have a way to help you remember those. And so if we remember the sentence, people really hate elephants on cars, that can help us to remember the steps. Or you can remember this picture of Mr. Arcuri standing on top of the car, and that might help you to remember the steps. So if you remember one of those things, then you can remember the steps. The first letter of each word stands for one of the steps. P-R-H-E-O-N-C. Does anyone think they know what any of those letters might stand for? Really, you think you know them? Yeah, the H does stand for hypothesis. Anyone know a different one? Frank?
Problem.
Yeah, the P stands for problem. Bailey? The C stands for conclusion. You guys know some of these already. Any others?
The E next stand for experiment.
E, experiment.
Research.
R, research. We're missing only one, right?
Oh,
What about the O?
uh,
Nuh-uh. Go ahead. So we talked about this on the very first day of school.
oh, I know it.
I'm going to move on, Rania.
Observation.
Observation.
Yeah, I knew that.
So those are our steps of the scientific method. Go ahead and write them down. Problem,
Oh, yeah.
research, hypothesis, experiment, observation, conclusion. Those are the steps of the scientific method. And like I said, you are going to have to remember them. I guess if your page was open on both sides, you could see the steps already. There's that.
Oh, it says it right here. So.
Yeah. So if you remember the sentence, you remember the steps. But not only will we have to know what the steps are, we have to know sort of what they mean. And so I know you've heard some of these words. Others might be new to you. So let's start with the first one, the problem. So, oh, there's another picture. The problem. So when we start off and we're trying to learn some new information, scientists start with a problem. And in this, the problem is a question that we're asking. A question that we're asking. Now I may want to know, do students do better on a math quiz if they eat beforehand? If they eat a sandwich beforehand? That's a question I could ask, and I can try to set up an experiment that would help me to answer that question. So that would be my problem. That's the first step. Second step then is you need to do a little bit of background research before you can start setting up your experiment. Gather some other information to help you prepare. For example, I may have to find like a math quiz that I can give everybody. an appropriate and difficult. I may need to have to research if any of my subjects have allergies to any foods. So I need to get some information before I can really get going on my experiment.
Oh.
All right, so we have a question, we research it a little bit, and then we can start to work on our hypothesis. Now, I know many of you can give me a definition of hypothesis, but I'm gonna change it on you. I know the definition you want, so who can give me the definition that you know for sure? A hypothesis is what, Faith?
An educated guess.
That's what you guys learned in elementary school, educated guess. That's an okay definition, but I have a better one, okay? It is an educated guess, sort of, but really what you're doing when you set up your hypothesis is you're making a prediction. You're saying, I think this is what's going to happen in my experiment. I really like prediction better. So it's a prediction about what you think is going to happen. That's what your hypothesis is, your prediction. Before you even do your experiment, you sort of guess as to what the outcome is going to be. So my question I'm asking is, would students do better on a math quiz after they eat a sandwich? What's your hypothesis about my problem? Sophia?
I'd say it depends because if the kids need to have like the same type of like average or
Okay.
subject in the unit.
Okay, let's say that for a minute in our next one. You're right. But first, your hypothesis. What do you think? Let's say we have a good experiment.
Yes.
So, yeah, it's just yes. I think students would do better on a math quiz if they eat a sandwich. Or maybe your hypothesis is, no, I do not think they'll do better after they eat a sandwich. You just sort of make your prediction. What do you think? And it's okay if it's wrong. Doesn't matter. You don't go back and change it when your experiment's done, because you still learn some valuable information even when your hypothesis is wrong. Okay, so we have our prediction. Well, somehow we need to test our prediction. We need to see if our hypothesis was correct or not. And that's what the experiment is. The experiment is some kind of procedure, some activity that you do to see if your hypothesis is correct or not. All right, let's talk about my example again. How would I do that then? You know what my hypothesis was. Students will do better on a math quiz if they eat a sandwich beforehand. So how could I see if that's correct? Bailey?
Have two people take the math quiz, one eats and one does not.
Okay. Have two people take a math quiz. One eats the sandwich before, one does not. So what were you talking about a minute ago?
That it was that it would like depend on in order to do it if they had like the same average in that subject.
Okay.
Because it wouldn't be fair if they didn't.
Yeah, so then we have to think about, okay, well, some students might be better in math than other students. And what if the one eating the sandwich just happened to be a better math student? We might think that they're doing better because of the sandwich, but when really they were just a better math student. So that's something we have to think about. How can I solve that problem? I could think of a couple things I might do. What's one thing, Sophia?
First, you could have them both take the test and eat the sandwich before it's in the
Okay. I could use the same people in my experiment, just on 2 different days. So maybe I have this class take a math quiz today without eating a sandwich before. And I see what our grades are. And then tomorrow when you come in, I give you, should it be the same math quiz? What would you say? What should it be though? similar, about the same difficulty, you know, maybe same types of problems. But tomorrow, I give you all a sandwich to eat before, and then take the math quiz. And then we can compare. Now we're a little bit better shape because we know we have the same people are taking, so their math ability is the same today as it is tomorrow. So we're going to get a better result. We can be more confident in our answer. Okay. My next step then is I make some observations. Observations in a science are when you're collecting data from your experiment. You're observing what happened in your experiment. What kind of data do I collect in my experiment that I'm talking about? What would be the data, Frank? Yeah, the math grades, how they did on this quiz. That was the data that I would collect. And my last step then is to make a conclusion, to say, okay, now I have my experiment, I did it, I have my observations, okay, and now I come up with a conclusion. When you make your conclusion, what you do, you basically say, all right, I did my experiment. Was my hypothesis correct, or was it incorrect? Did the data support my hypothesis? You make that conclusion by looking at your data. Sometimes your hypothesis is supported, sometimes it's not, and that's okay. Let's say in my example experiment that the grades were the same on both days. What would the correct conclusion be then, if the grades were the same? Faith?
That it didn't work.
Well, yeah, that my hypothesis was what?
Was wrong.
That was wrong, was incorrect. The data did not support my hypothesis in that experiment. Any questions about the steps? All right, let's do one more example then. Let's say I want to do an experiment with mice or rats. Okay? I'm going to ask a question. That's my problem. The question I want to ask is, do mice grow larger if they are given vitamin C? That's a question I could ask. That's a question that I can set up an experiment and answer that question. Before I really set this up, though, I need to do some research. What kind of things would I have to know before I can actually do this experiment? Vinny?
Like how old they're,
How old? What is?
like the mice, like
Yeah, I think I would want to know how old the mice are. What else, Olivia?
if they have rabies.
Okay. Yeah, I'd like to know if they have rabies. That's good. I wouldn't want to be working with mice that have rabies. What else? Sophia?
Like if the mice, they're
Really?
not.
How big they start? Okay. Maybe I need to know, like, what do I feed mice? What kind of cage do they need to stay in? Things like that. Just sort of background information. How am I going to give them vitamin C? Where do I get vitamin C? Do I give them drops or what? So those are all little pieces of information I want to know in advance. Okay, so now I need to make a hypothesis. Somebody give me a hypothesis about this experiment. What's a hypothesis you might have? Well, somebody else that hasn't given much. I heard from you a couple times, Bailey. Anybody else? Your hypothesis. The question I'm asking is, do mice grow larger if they're given vitamin C? Ryan, what do you think? What's your hypothesis? Doesn't matter if it's right or wrong. What do you think? Would grow larger? Okay. That's Ronnie's hypothesis. How many people that's your hypothesis? You think mice will grow, if mice are given extra vitamin C, they'll grow larger? Ron, yeah, I know. Okay, couple? Just a couple of you? Everyone else thinks so? Okay. So, that's up to you. Some of you could have different hypotheses, that's fine. If mice are given extra, then they'll grow larger. Or maybe you think if mice are given extra vitamin C, they will not grow larger. It's up to you. You come up with your own hypothesis there. But again, this is what we're going to test. This is what our experiment is set up to test, whether or not that hypothesis is correct. How would I actually do this experiment? What would I do? You could sort of walk me through an experiment that would test this hypothesis. Frank?
Have two mice and see which one grow, one like vitamin C, like the other one gets vitamin C, the one see what one grows bigger.
Okay. Give me some more details. So I like how Frank started. What else would what other details do I need here? Bailey?
Like first start making sure there's some size.
Oh, that's a good point. So when we start our experiment, they have to be the same size. That's good. What else, Sophia?
Please make sure you give them the same amount of vitamin C.
The same amount? Okay, let's say I have my two mice. I give them the same amount of vitamin C.
Oh, I mean one. Wait, never mind.
Okay. Hey?
You have to give them the same amount of food and water.
Yeah, that they would have to get the same amount of food and the same amount of water. I have to keep that the same. What do I want to be the only difference, Sophia?
The vitamin C.
Yeah, that's going to be, hopefully, in my experiment, the only difference is that one's getting extra vitamin C and one is not. Okay, so, now let me say this. What if one of those mice was just some like kind of weird mouse that happened to be tiny and not grow much? Would that make a problem in our experiment?
Yes.
How can we get around that?
You do it again. You get a
Okay.
different mouse.
We could do it again, or instead of having two mice, one in each cage, what else could we do? What would be better than 3 mice?
4
Five
mice.
mice.
What would be better than 5 mice?
6 mice.
As many as, the more mice we have, the better our experiment is. The more reliable it is. We say it's more valid. Because just 2 mice, one might be sick or just happen to be a small, but if we have 100 of each of mice, 100 given vitamin C, 100 not, well then we can be more confident in our results. So we want usually a lot of, we call those samples.
Are we really going to do this?
No.
Sorry.
No, I would not have.
We will do some other experiments. All right, and then don't look at that. You didn't see that. It never happened.
Oh man.
Sorry, you should, you're okay. Observations. So what would I observe as this experiment's going along? As I have my 2 cages of mice, I'm giving them the same food, I'm giving them the same water, but I'm giving 1 cage the extra vitamin C. What do I observe from this experiment? How about someone else? I've heard a lot from Bailey and Sophie. And Faith. And Lily. Somebody else. So what would I observe in this experiment? So I got my 2 cages of mice. It's been a week, and I want to know, okay. Good.
If they're like getting bigger.
So what am I going to observe? Like, what exactly would I measure? Their size. What about size? Like, that's not that specific.
Like, I get a tape measure.
Yeah, maybe the length of the mouse. Maybe, what else could I do, Brennan?
Their weight.
Maybe the mass? Good. Yeah, those are things I could measure. Here in my example, I said weight, but length would be fine. I weigh the mice after 2 weeks. And let's say my observations are that the vitamin C mice weigh the same as the non-vitamin C mice. Bailey?
Has this experiment actually been done before?
Not that I know of. Why, you want to know what the real answer is?
Yeah.
Why don't you, do you have any mice at home?
No.
Probably buy something like PetSmart and do this experiment.
I don't want to touch mine.
They're cute. I've ever seen little white mice. They're actually kind of cute.
They're from the sewer. They.
Living mice?
No, they're frozen in there.
Frozen dead mice? Oh.
Ew, that's gross.
Really nasty.
I used to have a snake and my snake ate one.
Okay. All right. Well, if these are my observations, what would my conclusion be? So this is my observation. Frank, what would you say for a conclusion here? And my hypothesis was incorrect. In this example, the mice did not grow larger when given extra vitamin C. Is it okay that my hypothesis was wrong?
Yeah.
Should I go back and erase it?
No.
No, it's okay. Your hypothesis can be wrong. That's fine. Okay. You still learned something. I've still learned some valuable information from my experiment. Okay. It's just not what I had predicted. Okay.
Sway.
He's the man.
Sway. Again.
So why is Mario here?
Because he is awesome.
He is pretty awesome. Although I'm more partial to
Yeah,
I'm more partial to Luigi myself. No?
He's a star.
What?
He's a star, that's why.
So, do you guys ever
Yeah.
use the scientific method?
Not really.
When's the last time you sat down and wrote out your problem, research, hypothesis?
Last year.
Yes, in science class probably. All right, so, but that's not the question I asked. Do you ever
Yes.
do the scientific method and maybe not formally write it down and think about it this way? What would be an example of you doing an experiment?
I've heard about that.
Playing like Mario Kart and saying you're gonna beat your friend and you don't.
Okay, let's go a little, let's use Mario Kart as an example. Okay. So your hypothesis, we need to have some variables there. So what is a hypothesis you could test? Not just that you beat your friend, because your friend might just be better at Mario Kart than you, right? So let's go a little bit farther.
You don't run to the wall.
Okay. All right. Well, I need a couple groups here and stuff. Sophia,
That Mario is better than Luigi.
how would you do that?
Because he beat Bowser.
How would I set that up?
You could like do it like I don't know, have like a computer do it. Like, I don't know.
Okay. Bailey?
You could play one round as Mario and next round as Luigi.
Okay. So maybe you have the same person, right? Because you want to be the same ability at Mario Kart. One round you use Mario. The next round you use Luigi. What do you have to be sure? Should you do, you have to be sure, do you want the one in space and then the other one is the desert track? I forget, I don't know what they're called. I did too, I always fall.
Me too.
Yeah. So no, what do you have to do, Sophia?
You have to make sure that you have like you do the same course and you ride it in the same like you use the same car.
You need the same track. What's the star one called?
Rainbow Road.
Rainbow Road. So you want to do them all on Rainbow Road. You want to use the same car. You don't want to use a 25cc car one time and then the 50cc car the next time. You have to use the same car. What would your hypothesis be? Whose hypothesis is that Mario would win? Wow. Luigi?
Yeah.
How about the same? No one thinks the same? Does changing a little character change how he races? I wouldn't think so. I don't know. I'm not sure about that. But you can conduct that experiment at home if you want when you get home this weekend. That can be your task. So yes, my point is we do use the scientific method all the time. You just don't really think about it. You know, maybe you play a sport. Maybe you play soccer and you want to know, well, if I